Given a linear programming problem whose objective function is z is equal to 4x plus 3y and the feasible region determined by set of constraints as shown in the graph. And here we can see that the feasible region in the solution part is bounded. It's a bounded. So let us see the corner points. P, its corner points are P 0, 40 and Q 30, 20, R 40, 0 and 0 origin O 0, 0 and its value of the objective function at this corner points. Let us see z is equal to 4x plus 3y. So here we can write 4 times of 0 plus 3 times of y coordinate is 40. So 0 plus 120 and here 4 times of 30 plus 3 times of 20, that is 120 plus 60 is 180 and here 4 times of 40 plus 3 times of 0 which is 160 and here 4 times of 0 plus 3 times of 0 which is equal to 0. So the value of objective function, clearly we can say that it is maximum at the point Q 30, 20. Since it is a bounded region, so we can obtain the maximum value or minimum value at the corner points. So here maximum we are getting it 30, 20. We can consider the answer is option B. Maximum value of z is at 30, 20. So we need to find the integral 1 upon x to the power of 3 of 1 plus x to the power of 4 whole to the power 1 by 2 dx. So let us take common x power 4 within the bracket. So we'll get 1 upon x to the power of 3 x power 4. So we can add 1 by x power 4 plus 1 whole to the power 1 by 2 dx. So we can add 1 upon x to the power of 3 into x power 4 whole power 1 by 2 is x square of 1 plus 1 by x power 4 whole to the power 1 by 2 dx. That is integral 1 upon x to the power of 5 times 1 plus 1 upon x power 4 whole to the power 1 by 2 dx. Let us substitute or put 1 plus 1 upon x power 4 is equal to t. So on differentiating, we get minus 4 divided by x to the power of 5 dx is equal to dt. Or we can add minus 1 upon x power 5 or 1 upon x power 5 dx is equal to minus dt divided by 4. So on simplifying, we can get integral. So we can mark here 1 upon dx upon x power 5 can be taken as minus dt upon 4. So minus dt upon 4 and 1 plus 1 upon x power 4 is t. So t to the power of 1 by 2. So that is minus 1 by 4 integral t to the power of minus 1 by 2 dt. So which is equal to minus 1 by 4 t to the power of minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus some integral constant c. Or we can write minus 1 by 4 into t to the power of 1 by 2 divided by half, which is minus 1 by 2 root t plus some constant. Or we can write minus 1 by 2 into under root of 1 plus 1 by x power 4 plus some constant, or we can add minus 1 by 2 x square under root of, by taking LCM we'll get x power 4 plus 1 plus c. So minus 1 by 2 x square root of x power 4 plus 1 plus c is the answer, which is option A. Option A is the answer. We need to find the integral 0 to 2 pi cosecant power 7 x dx. So let us consider f of x is equal to cosecant power 7x. Then f of 2 pi minus x is equal to cosecant power 7 of 2 pi minus x, which is equal to cosecant 2 pi minus x whole power 7, that is minus cosecant x, because 2 pi minus x is in fourth quadrant, it is negative. So minus cosecant x whole power 7, that is minus cosecant power 7x, which is equal to negative f of x. We had a property integral 0 to 2a f of x dx is equal to 0 if f of 2a minus x is equal to minus f of x. So here we can say that f of 2 pi minus x is equal to negative f of x. So in this case we can say integral 0 to 2 pi cosecant power 7x dx is equal to 0. So option A. We need to find the general solution of the differential equation e to the power y dash is equal to x. So we can also write it as y dash is equal to log x to the base e by converting logarithm to the exponential. Y dash is nothing but dy by dx. So we can write dy by dx is equal to log x to the base e, or we can write dy is equal to log x into dx, which is base e. Now integrating on both the sides, so we get integral dy is equal to integral of log x dx, and we know that integration of log x we can find it by log x into 1 dx. By using the fg rule, integral of fg is equal to f into integral of g minus integral of f dash into integral of g. So here we can write log x into integration of 1 dx minus integration of differentiation of log x is 1 upon x into integration of 1 dx is x dx plus c, that is log x into integration of 1 dx is x minus integration of 1 dx is x plus c, that is x log x minus x plus c is the integration of log x. So we can write integration of 1 dy is y. So y is equal to x log x minus x plus integral constant c. So which is our option B. We need to identify the graph. Either it is sine inverse x, cos inverse x, cosecant inverse x, or cot inverse x. Let's see the domain of the function. We can see that the domain on x-axis from -1 to the graph is from -1 to +1. So we can write domain of this function graph is -1 to +1, and the range of this function we can see that from 0 to the graph is existing from 0 to pi. 0 to pi, and clearly we can say that we have the domain of cos inverse x is -1 to 1 and range is 0 to pi. So we can conclude this is the cos inverse x graph. So option B is the answer. Given a linear programming problem along with the graph of its constraints, the objective function is z is equal to 18x plus 10y, which has to be minimized. The smallest value of the objective function is given 134 and obtained at the corner point 3, 8, it's mentioned. And here we can see the constants. 4x plus y is equal to 20. This is one line. And the shaded region is away from the origin. And another constraint, we can see that 2x plus 3y is equal to 30, and the shaded region is away from the origin. And in the first quadrant, x is greater than or equals to 0 and y greater than or equals to 0. Since the feasible region is unbounded, so this is unbounded, so we need to consider the profit function, this 18x plus 10y. Since we need to be minimized, so we have to consider the function 18x plus 10y is less than, and the point of intersection is here at the point 3 comma 8, and it is 134. The objective, the value is given, so less than 134. And this line 18x plus 10y is equal to 134, we can see that this line less than 134, which is towards the origin and which does not have any point in common with the feasible region, and hence we can say that this function linear programming problem as having a minimum value 134. We can consider this as a 134 is a minimum value obtained at the corner point 3 comma 8. So 18x plus 10y less than 134, it does not have any point in common with the feasible region and it is existing. So we can go with an option D. Option D is the answer. Given function f from real numbers to the integers defined by f of x is equal to greatest integer function or step function. We need to check whether this function is continuous and differentiable at x is equal to 2.5. We know that step function is not continuous at integral values. That is, for x belongs to z, this function is not continuous, and remaining everywhere it is continuous. Let's see the graph. From 0 to 1, the step function is 0. And from 1 to 2, we can say it is 1. And from 2 to 3, it is 2. Clearly at 2.5, you can see that the value is 2. And in the neighborhood of 2.5, in the left neighborhood and right neighborhood, means 2.5 minus h and 2.5 plus h, as h tends to 0, we can see that the value is remaining constant, that is f of x is equal to 2. It's a constant function, so it's a straight line moreover. So this graph is continuous in this neighborhood, and also the function is a straight line and it is continuous and it's differentiable. So we can say that at x is equal to 2.5, this function f of x is equal to step x is continuous as well as differentiable at x is equal to 5. So we can go with an option D. A student observes an open air honeybee nest on the branch of a tree whose plane figure is a parabolic shape given by x square is equal to 4y. So let's see the graph. X square is equal to 4y is an parabolic curve open upwards direction and whose vertex is origin. And this graph is symmetrical about y-axis. and then the area of the region bounded by this parabola and the line y is equal to 4. We can see the line. So this is y is equal to 4. Then the area of the region bounded by this. So we can write by using the integrals, area of the required region which is equal to 2 times integral. Let us consider along the y-axis, that is 0 to 4, and the curve. So here x square is equal to 4y, or we can write x is equal to root of 4y, that is 2 root y. So 2 root y dy, which is equal to 2 times into 2 into y to the power of 3 by 2 divided by 3 by 2 over the limits 0 to 4, that is 2 into 2 by 3 into 4 to the power of 3 by 2 minus 0, upper limit minus lower limit. So this is 8 by 3 into 4 to the power of 3 by 2 is 2 to the power of 3, which is equal to 8 by 3 into 8, which is 64 upon 3. 64 upon 3 square units is the area formed by this parabola curve and the line y is equal to 4. So we can go with an option B. In assertion, given function f of x is equal to mod x plus mod of x minus 1, where x is a real number, and it's also mentioned that f of x is not differentiable at x is equal to 0 and x is equal to 1. Let's check this through the graph. Given f of x is equal to mod x plus mod of x minus 1, let's break into 3 intervals. Whenever x is greater than or equals to 1, so both the modulus are positive, so x plus x minus 1, which is equal to 2x minus 1, we can write. And when x lies between 0 and 1, so mod x is positive x and mod of x minus 1 is negative. So we can write x minus x plus 1, which is equal to 1 constant you are getting. And whenever x is less than 0, so both are negative. So minus x minus of x minus 1, which is negative 2x plus 1. So we can define the function as whenever x less than 0, so the graph is minus 2x plus 1, and when x lies between 0 and 1, it's a 1 constant function, and when x is greater than or equals to 1, so we can say the graph is 2x minus 1. Let's sketch the graph here. 0, 1. From 0 to 1, the graph is constant, so it is 1. So at x is equal to 0, it is 1, it is included, and 1 here. And x is greater than or equals to 1, we can see the graph 2x minus 1. Say this is 1 here, function. At x greater than or equals to 1, 2x minus 1. So when x is equal to 1, it is 2 into 1 minus 1, 1. And x is equal to 2, 2 to the 4 minus 1, 3. Since it is a linear equation, it is a straight line. You will get. So here is the graph 2x minus 1. And here it is 1. So y is equal to 2x minus 1, y is equal to 1. And below 1, below 0, we can see negative 2x plus 1. So when x is equal to 0, it is 1. When x is equal to minus 1, it is 3. So we can see the graph here. Minus 1, it is 3, same as plus 2. So this function is y is equal to negative 2x plus 1. And clearly we can see that in the right derivative, y is equal to x minus 1. At this point, the derivative is y dash is equal to 2. And here at this case, the y dash is equal to 0 for y is equal to 1. And here in this case, y dash is equal to negative 2. So at the point x is equal to 1, the left derivative is 0 and the right derivative is 2. So this is left hand derivative and right hand derivative. Both are not equal. And hence we can say that at x is equal to 1, at x is equal to 1, it is not differentiable. And at x is equal to 0, we can see the left derivative is minus 2 and the right derivative is 0. So here also we can say that at x is equal to 0 also the given function is not differentiable. And hence we can say the assertion given is true. And also we can also mention that these are the two corner points. We are getting a corner point, sharp edge. At these two edges, there is no differentiability. So at 0, at x is equal to 0 and x is equal to 1, not differentiable. And the reason given, suppose f be a defined and continuous on open interval a comma b and for c belongs to a comma b, f of x is not differentiable at x is equal to c if limit h tends to 0 minus f of c plus h minus f of c divided by h. This is left hand derivative formula, and which is not equal to limit h tends to 0 plus f of c plus h minus f of c divided by h, which is right hand derivative. So left hand derivative is not equals to right hand derivative, it is mentioned. So accordingly, the assertion also we got the same. Left hand derivative is not equal to right hand derivative at the 2 points x is equal to 0 and x is equal to 1. So we can say the reason is also true, and this is the correct explanation of the assertion. So option A is the answer. Given assertion, the function f from r minus odd multiples of pi by 2 to minus infinity to minus 1 union 1 to infinity is defined by f of x is equal to secant x is not 1 to 1 function in its domain. Is secant x graph, if you can see. So let me draw the first cos x graph. Zero. Say this is pi by 2, pi and 3 pi by 2, and this is minus pi by 2, minus pi and minus 3 pi by 2, and here it is 1. So this is minus 1. And secant x graph can be taken at pi by 2, it is not defined. We can say that at x is equal to pi by 2, at x is equal to 3 pi by 2, there is no graph. At x is equal to minus pi by 2, odd multiples of pi by 2, graph is not there. We can draw the graph. And here it comes below this curve and below this curve here. So means above 1 and below minus 1 the graph. So the range output of the secant x graph is it is above 1 and below negative 1. And we need to prove that this function is not 1 to 1, or we need to check. Clearly we can say that x is equal to 2. Let us take this is 2 point. If I can draw one horizontal line, it cuts at more than 1 point. means for two different values of x, for two different values of x here, say x1 is not equals to x2, we can see like f of x1 is equal to f of x2, which is equal to 2. So which is against to the definition of one-to-one function, as one-to-one says two distinct images will have two, for two distinct elements have two distinct images. So for x1 not equals to x2, f of x1 should not be equals to f of x2. So here it is against to that. So we can say this function is not one-to-one, because the reason for line y is equal to 2 meets the graph of the function at more than one point. That is also correct explanation. So we can say the assertion is true and reason is also true and it is a correct explanation. So we can go with an option A.